All right, today we want to look at this very important question. Most times when students see this type of question, they will be very, very afraid. Why? Simply because of the diagram. If you look at the diagram alone, if you don't understand the rudiments of the diagram, then you'll be thrown off balance. But here in this video, I want to teach you how to analyze the diagram bit by bit so that you'll be able to solve the questions of any sort as far as this type of diagram is concerned. All right, if you they asked us to find the current. Look at the diagram. Look at the current here. I is the current, remember. Then, if you look at the diagram very well, you find out that it has three major components. The first one is the voltage supply, which is 12 volts. Then this one is the current. You can see the direction of the current flowing. Then we have a network of resistors. We have 1, 2, 3, 4, and 5. There are 5 resistors there. But what matters here is how to analyze these resistors, how to analyze them and then get the equivalent or the total value of the resistance offered by this diagram. Okay, then if you look at this from here, okay, let's start from the direction of the current. Look at the straight line here. Is a straight line until it gets to this place. This is one resistor of resistance 1 ohm. Then this resistance is in series until it gets to this junction. This junction makes it what? Parallel. So we have a branch from the upper part, another branch from the lower part here. So what it means is that these 2 ohms and these 2 ohms here, they are in series. All right. Then from the lower branch here, we have 2 ohms here, then we have another 2 ohms. They are also what? In series. So 1, 2 are in series, 1, 2 are in series. What we're going to do is to add those ones in series. Then when you add this and this, you get 4. And then when you add this and this, you get 4. So the simplified diagram, let's see a simpler diagram to this diagram. And then we're going to have something like, okay, adding 1, 2, we have 4. That means from the upper part, we have 4 ohms. This was gotten by adding this one and this one, all right? Then from the lower part here, all right, from the lower part, we now have 2 plus 2. That is another 4 ohms. Then we now join it. Remember, we have added these 2 to get 4. We added this other 2 to get this 4. Then there is a junction here. So we now have the junction. That is this junction. Remember, we still have 1 ohm resistor, this other part. Then we now have this type of diagram. Okay, this is a simpler diagram to the other one. Remember the direction of current, and then we have 12 volts here. This diagram is simpler to this other one. So going further, we are going to analyze this one and this one again. This 4 ohm and this 4 ohm are arranged in parallel. Okay, so when 2 resistors are arranged in parallel, for us to get the equivalent value, all we need to do is to make use of the formula product over sum. That is, the effective resistance in this case is equal to product over sum. That is R1 R2 all over R1 plus R2. This one is our R1 in this case. This one is our R2. So simply substitute the values here in this formula. That is 4 by 4 all over 4 plus 4. 4 times 4 is what? 16 divided by 4 plus 4 is what? 8. So when we now cancel out, we now have that this one will go 1, this one goes 2. So our resistance is now what? 2 ohms. That is, we have simplified these 4 ohms and these 4 ohms to get the equivalent of what? 2 ohms. So our diagram is going to look like this. It's going to look like this. We now have 2 ohms. That is these 2 ohms gotten from this and this. Okay, then we now have the remaining one, which is this resistor here, and then we label it 1 ohms. Okay, then going further, we still represent our diagram like this. We still have 12 volt supply, 12 volts, and then the direction of the current I. Okay, then what we are going to do now is to look at the 2 resistors that we have. You know, we have 2 resistors here, 1 and 2. The resistance of this resistor here is 2 ohms. The resistance of this other one here is 1 ohm. And if you look at the two of them, they are now arranged in series. That is end to end, straight line. So what we're going to do in this case is to add them straight up. When resistances are arranged in series, all you need to do to get their equivalents is to add them straight up. Then, in this case, our R is equal to 2 plus 1. That is these 2 ohms plus this 1 ohm. And it gives us what? 3 ohms. So the value of the entire resistance here from this diagram is equal to what? 3 ohms. So what we're going to do now is to make use of the Ohm's law for us to be able to calculate the current. Remember that it is current that we are finding. So from Ohm's law, V is equal to IR. V is equal to IR. So we are looking for the I in this case. Our I now is equal to V over R. And that is, V in this case is 12. R in this case is what? 3. That means 12 over 3. And that gives us 4.0 amperes. And that is the final answer. I believe that this question is very simple. Just follow it bit by bit and you don't have any problem analyzing network of resistors according to this diagram. Thank you very much and bye-bye.